146. Total gain without feedback is multiply both AV1 into AV2. 82.7 into 146, you get 13,155. See how much huge amplification is provided by your voltage series feedback pair. So usually single amplifier will provide a voltage gain of 82.7 or 146, but when you multiply the both or connect them in cascade, you get a very huge gain, 13,155. Now find beta. You know beta formula is R1 by R1 plus R2. Sorry, beta is R2 R1 by R1 plus R2, and here it is going to be R4 by R3 plus R4. So beta is 1 by 79. So AV beta you can find AVF equal to AV by beta. Okay, and the input resistance with feedback RIF equal to RI into 1 plus beta AV, and RI is going to be HIE, because that is the input resistance without the external components. I again say, when you find Ri and R naught, it is only for the device. Whatever biasing resistors, whatever load you have connected, you can neglect that. Okay, here Ri is the input resistance of your first transistor, which is HIE 2K. So when you multiply Ri into 1 plus beta AV, you get the answer as 335. And this is justified when voltage series feedback, the input resistance with feedback will increase from the original value without feedback. Without feedback, it is 2K. With feedback, it is 35K. Okay. R naught F. So R naught F is R naught 2 by 1 plus beta AV. Already we found out R naught 2. R naught 2, we already got it. So, okay. So, you can find R naught 2. It is 2.95 kilo ohm, and substitute in R naught F, you get 17 ohms. It is very, very small. And here also it is justified when you find the output resistance for voltage series feedback. The output resistance with feedback will reduce from the value without feedback. So R naught F is 17.61, and R naught 2, you see, it is 2.95K. See, this value, whatever they have found in the second step, is R naught 2. Okay, they don't mistake it to be R naught F, it is R naught 2.